Okay, so let me get the paper. All right, so on that first side, number 1, it says. Calculator. All right, let me get everything. Hopefully, this is what it did to me this morning. It froze up. Okay. Here we go. Okay. My x squared minus 8x, and I don't know what you have in there, so make sure. Nothing else to cooperate today. Did it come up to calibrate? Better now. Okay, x squared minus 8x plus 7. All right, let me go back. Oh. Okay, there we go. All right, so we've got this quadratic there. Does everybody's look like that on that standard window? So you go to your y equals and you type in that equation, x squared minus 8x plus 7.
Is there a way from our Chromebooks to access that thing?
No, there is not.
Like, is that just something they give you as a teacher?
Give me what?
Like a little app.
No, they don't give you anything. You have to buy it.
How much is it?
It's $200,
That's kind of expensive.
which is why you have a calculator.
If you look hard enough, you can get free ones.
Well, how about you do that then? You spend all your time doing that. All right, does everybody have this one in there? Yes. Oh, I'm sorry. Okay, so x squared minus 8x plus 7. Is everybody there now? Okay, so the first thing, we're going to do the vertex. Now there's 5 things we're going to answer, and I've got them written over there. The vertex, the AOS, which is the axis of symmetry, the roots, which are also called the x-intercepts, the y-intercept, and whether it's a maximum or a minimum. Well, looking at that graph, is it a maximum or a minimum?
Maximum or minimum?
It's a minimum. Where is the lowest point? Right here. That's a minimum. How do I know that without looking at the graph? On the equation, a is positive. A is the number in front of the x squared. So a is positive. So I know it opens up, and if the parabola opens up, it's going to have a minimum. It's going to have a low point. So on my paper, let's see. You've got, let me kind of write it down like you have it. All right, so the first thing right below here, it says maximum or minimum. And we've decided, which one is it?
Minimum.
It's a minimum. So we're going to circle, it's a minimum. Okay, now we've got a graph over there. The domain of this parabola, remember the domain are the x values. The x's go left and they go right. Remember, this is the negative x, this is the positive x. So does this parabola, even though it stops here and here, does it ever quit going up? No, so it keeps going to the left, correct? Does it ever quit going up this way, to the right? No, so it keeps on going this way. So how do we represent every possible number on that x-axis? Not infinity. There's one symbol that we write. And I always tell you, it is not a T and an R that you're writing down, because some of you make it look like a T and an R. Thank you. The domain, remember, are the x values, and just what Lexi said, it's an R with an extra line. But what does that mean? It does mean from negative infinity to positive infinity, but what does that R stand for? We've discussed it over and over. If you don't have this in your notes, you should have it in your notes from where I did this problem. all real numbers. That means every possible number, positive, negative, fractions, decimals, every number is possible on that parabola, every x value. Now the range, if domain is x values, the range is the y values. Okay, now looking at the range, remember the range are the y's. So we're looking at, does it ever stop going down or does it ever stop going up? So is there a low point on this parabola? Where does it stop going down? There's a hint. If there's a minimum, then yes, it stops going down, correct? It stops at that point right there, doesn't it? So we've got to figure out this point, but that point is also called the what? The what of the parabola? Guys, I'm up here. What is the point where it changes directions? The vertex. This is the vertex. So we're going to calculate that vertex. So second, calculate. If you don't know what I'm talking about, you're going to be up a creek on this test tomorrow. So we're calculating the minimum, which is number 3. Remember, the calculator says, okay, put me to the left of that vertex. So we're going to move our cursor down to the bottom left. We're going to hit enter. It says, okay, now put me to the right of it. So we move our cursor to the right of it and hit enter. You want to get it as close to that vertex as you can without, going over it. And then the calculator says, okay, you ready to guess? And you hit enter again. Now, what is this 3.9999994 round to? 4. That means it's 4 negative 9. So our vertex on our paper, our vertex is 4 negative 9. Right? Now let me come back to this just a minute. What we wanted to do was find that point on that minimum. We wanted to find that point right there, which we just did, 4 negative 9, right? All right, we're talking about the range. What are the range? Are they the x's or the y's? All right, I'm about to sit down and stop and let y'all just do this yourself. Because I got people messing with their calculator, and you shouldn't be. I got people drawing. I got people not paying attention, not looking up here. So why am I bothering? So if you want my help, I suggest you start participating. If you want to do it on your own and probably fail, then continue like we are right now. Don't say nothing. Sit there like knots on locks, like mutes. I'm going to say again. We were talking about the range, which are the y values. We just found the vertex to be 4 negative 9. We need to know that part right there. Did we just find it? Yes, 4 negative 9. What is the y part of that vertex? Thank you, negative 9. So the lowest point on this graph for the y is negative 9. What's the highest point? Does it ever quit going up? No. So your range values are going to be y is greater than or equal to negative 9. Because it can be anything from negative 9 up. So we've got the minimum circled, we've got the domain completed, we've got the range completed. Now, you've got a table of values over here. We marked out the intervals of increase or decrease. You've got a table of values. Go ahead and write an x, y there. Well, I've got x and f of x in there. And I've got 5 spaces for you to write points. Your vertex is going to go right in the middle. Because your vertex is your middle point on your parabola. It's that point where it changes directions. Okay, so your vertex is going to go right in the middle. Now over in the top corner above that table I have AOS there. Well, the axis of symmetry is just the x part of the vertex. It's an equation. You have to write x equals 4. So you have x equals 4 down there. It would be great if you were writing this on this paper or in your notes at this moment. So now we're going to find other points to the left of it and to the right of it. Well, looking at our graph, how do we find other points? Where do we go to in the calculator to find the other points? Do what? You might have said it, I don't know. Where do we find our other points? I'm going to sit here and wait. Where on the calculator do we go to find the other points on the graph?
Window?
Not window. The window changes how we see it. We could do trace, but it doesn't give it to them all at one time. What did you say, Dylan? Table. How do we get to the table? Second and graph. Okay? So we go second graph. And we're going to find our vertex. So our vertex is right here, 4, -9. So I'm going to go down so I can see some points below it. And I'm going to see some points above it. So right here's our vertex, 4, -9. So I'm going to write down the 2 points here, and I'm going to write down the 2 points here. So in my table, I'm going to put 2, 3, 5, 6, and then I'm going to write -5, -8, -8, -5. So 2, 3, 5, 6. What was it? -5, -8. Whoops. -5, -8, -8, -5. So I've got the 5 points I need to graph. My vertex is in the middle. I got 2 points on the left of it and 2 points on the right of it. You got to know where to find that in that table. So if you don't know where to do that, then you better be writing it in your notes so you'll know for your test tomorrow. So on your graph, when you're graphing your points, you have 4, -9. Let's make 3, -8. Well, actually, that should be over. So 4, -9. I think yours is on the very bottom point. 3, -8. 2, -5. 5, -8. And 6, -5. Still not writing correctly. I don't know what's going on with this pen. Anyway, so you'll connect your points and then draw your parabola there, your quadratic. And then we're not through. Alright, I'm going to walk around here in just a minute, and if you don't have this stuff on your paper, I'm sending you to the office. Plain and simple. If you do not have this stuff written on your paper when I walk around, you're going to the office. Everybody hear that? I've said it 2 times. I'm going to say it one more time. I'm going to walk around in just a minute, and if you do not have this stuff on your paper, you're going to the office. Said it 3 times. There's no reason for you to be sitting there doing nothing. Now, the only thing we have not done are the x-intercepts and the y-intercepts. So at the x-intercept, remember we called those roots, zeros, solutions, x-intercepts. They all mean the same thing, but where does it cross the x-axis? And most of these you can kind of look at the graph and tell. It looks like it crosses the x at negative or at 1 and at 7. And it looks like 1 and 7, but if we go to our table and it's a whole number, we will see zeros. We're looking for where y is 0, because y is 0 on the x-axis, so there's 1, 0, and there's 7, 0. So there's your x-intercepts given to you right there in the table. So your x-intercepts are 1, 0, and 7, 0. So it's where y is 0. All you got to do is look at the table. Now that's if it's a whole number. We did do this another way. We intercepted it with that y = 0 line, because y = 0 line is that x-axis. So when we did it this way, we said second, calculate, and we did number 5, the intersection, and then the calculator says, okay, put me at that intersection point. Doesn't matter which one you do, so I'll go over here to this one first. Oops. and you just hit enter 3 times. And there's your point, 70. You're going to have to use this when it doesn't give it to you in the table. So second, calculate number 5, intersection. Put your cursor over on the other intersection point. Hit enter 3 times. And there's your other intersection point, 10. So if you're looking for those zeros, those x-intercepts in the table, and you don't see any zeros in the y, then you're going to have to do the second calculate intersect. Okay? Now the y-intercepts is where x is 0. So what's the y-intercept? Pointing to it right here. 0, 7 is the x-intercept. How do we know that? By looking at the equation. How do we know the x-intercept is 7 by looking at the equation? It's that last number there, plus 7. That's your y-intercept. That's your starting point. So, I can tell I'm wasting my time with the majority of you. So, I'll tell you what we're going to do. If you want my help, I will be happy to help you. If you want to sit there and do nothing, then sit there and do nothing. So, we've completed that first one. I have all of these worked out on the front and the back. But you have, you know, I feel like I'm wasting my time, wasting my breath. I could be sitting down doing some other things. So I tell you what, if you want my help, and there's some of you that, you know, that are trying, I'll be happy to help you. But I'm getting very aggravated with about half of you at this point. So you've got number 1 done. You've got 2 more of those to do on the front of that paper. And then you have the problems on the back of that paper.